Welcome to the most comprehensive series on limits. In the last one, we discussed rationalization and factorization. In the current one, we are going to deal with infinite limits. I would highly recommend you, if you haven't gone through the older videos, the links are in the description. Please go over it. You are going to benefit a lot from it. So without any further delay, let us start with it. Type 7 problems are based on infinite limits. Now, what does this mean? So whenever we put in front of something as limit x tends to infinity, limit x tends to infinity, this would mean approximate value of the function when x is very large. That would ideally mean, if I take an example to understand it more clearly. So if I have limit x tends to infinity, x plus 2, this fundamentally means that if I draw the graph of x plus 2, so I am going to get a straight line that starts from here and goes like this. You can see that when we are going into very big values, when x is going towards infinity, you can see that the value of the function is also tending towards infinity. So very clearly you can see that the answer becomes infinity. But more importantly, it is talking about what happens when we are approaching infinity, or we can also call this as end behavior. So this is what it means, how it is going to behave towards the end. It shows us what is end behavior, and this idea, when we draw a graph, we are going to use this idea. So when we learn how to sketch curves, there we are going to use this idea of infinite limits. Now moving forward, if I again look into this idea using two more small examples, x minus 2, again if I draw the graph, you can see that from graphical point of view, the value is again becoming very large, so it becomes infinity. Also, if I do direct substitution, it would be infinity minus 2, that would largely tending towards infinity. Similarly, if I look into this, so if I draw the graph of this function, x square minus 4x plus 5, you can see that a is greater than 0. If I figure out the value of d, it is b square, that is 4 square minus 4ac. So this is 60 minus 20 comes out to be minus 4. So smaller than 0. And if I look into the value of minus b by 2a, this value will become 4 by 2. This is greater than 0. So the first information will tell us the shape, something like this. Second information says that it is above x-axis since d is smaller than 0. Third, it is saying that this is positive. So this midpoint is on the right side. So you can see that the graph will come something like this. You can see that as x is becoming very large, it is pointing upwards. So this will become. In fact, we do not need to draw the graph. Just look into the leading coefficient. It will tell us where it is pointed. So if a is greater than 0, infinity. If a is smaller than 0, minus infinity. Now let us move further. You can see that this question is given. So there are two standard ways to solve this question. In simpler questions like this, what we are going to do, we are going to generate a function of 1 by x. This is what we are going to do. For doing this, we are going to divide numerator and denominator by highest power of x in denominator. This is what we are going to do. If you follow this simple step, what is going to happen in this question? This will become limit x tends to infinity. If I divide by x, that is the highest power, this is going to become 1 minus 2 by x, 2 minus 3 by x. So now when x will become very large, the reciprocal to that very large number is going to become very small or tend towards 0. So wherever you have written 1 by x, this term will become 0. And as a result, answer becomes 1. You can see that this is a simple method and can be used in solving simpler questions. Let us look into one more question that is given to us. Now, important thing to be noted here is the highest power in the denominator is x cube. So now we are going to divide numerator and denominator using this x cube. So this becomes 1 by x minus 4 by x square plus 5 by x cube. The denominator will become 3 by x minus 1 plus 2 by x cube. We know that as x will tend towards infinity, 1 by x will tend towards 0, and as a result, answer becomes 0 minus 0 plus 0. This term becomes 0 minus 1 plus 0. This is nothing but 0 by minus 1. That comes out to 0. Very interesting question. Moving forward, another question is given in this form. We can use a similar idea. Now you can also try pausing the video and solving this question. In the meantime, who haven't got it can again look into the screen. So now what I can do is I can take x square common. So this becomes x. It should be mod of x, but since we are tending towards plus infinity, the mod will open with a positive sign. So 3 plus 2 by x square divided by 1 minus 2 by x. Now you can see that we have taken x common from numerator and denominator. It will get cancelled out. And now if I put the limits, the numerator becomes root 3, denominator becomes 1. So answer is root 3. Again a very simple question. Moving forward, now you can see that different kind of question is given to us. Now when the question becomes difficult, it would be like in this case, they are not asking us the limit directly. They are asking us the value of a and b if the limit exists and is equal to 2. So in this case, it will make sense for us, instead of doing this, do a little bit of substitution. So what I am going to do is substitute x by 1 by t. This is my second method. Usually we are going to do this when the question seems a little complicated. So we will not want to do it using earlier technique. Though it is totally possible, it can be done. It is just that it becomes complicated. So it is better if I do it in this manner. If I substitute this limit, then let us see what happens. So now what will happen to the limit? So now limit will tend towards 0. We learned this in substitution method. The numerator becomes 1 by t cube plus 1 divided by 1 by t square plus 1 minus a by t plus b is equal to 2. If I simplify this, it comes out to be limit t tends to 0. After LCM, it becomes 1 plus t cube. t square will get cancelled out to t plus 1 plus t square minus a by t plus b. Now you can see that it is something like infinity minus infinity form if you put the limit. So it will make sense. So this was my step 1. In my step 2, it would make sense to take LCM, because when we take LCM in case of infinity minus infinity form, it becomes 0 by 0, infinity by infinity form. If I take LCM, this becomes 1 plus t cube. The denominator would be common now, t into 1 plus t square. So this becomes a into 1 plus t square. The last term will become b into t into, so this t if I multiply, t plus t, and this value is equal to 2. So once I have done this, now it has become 0 by 0 form. Let us simplify it to observe it better. So limit t tends to 0. T cube coefficient, let us write it down, will now become 1 plus b. Then t square coefficient will become minus at square. Next term is t term, that will become b times t, and the constant term will become 1 minus a. So we have all the terms now. Divide by t times 1 plus t square. This is equal to. See, once you have this, now we can understand that if I am putting t equal to 0, what is going to happen? If I put t equal to 0, all of these terms, this is the next step. All of these terms will become 0. This will, it will be, if, now again we have two options. We did this question earlier. So in the third step, we are going to have two options. Either 1 minus a is equal to 0 or not equal to 0. If it is not equal to 0, this does not remain the finite limit. So this needs to be equal to 0. If I put this equal to 0, let us see what happens. The value of a comes out to be equal. So how do we get it? This is becoming 0. This needs to become 0 so that it becomes 0 by 0 form and hence solve. Now once you have got this and you rewrite the limit, your limit appears something like this. Limit t tends to 0. This is t cube 1 plus b minus at square plus bt divided by t into 1 plus t, and this is equal to 2. Now we can cancel out a t, and if I do so, it in turn becomes limit t tends to 0, t square times 1 plus b. This becomes at, this becomes b. This is 1 plus t. Substitute the limits. Once we substitute the limit, first part becomes 0, next becomes 0. B is remaining in the numerator, denominator becomes 1. If you simplify this, the value of b also comes out. A is equal to 1, b is equal to 1. You can see that this second and third step we did earlier also when we solved this question. How did we get to that step is nothing but putting this substitution. So what is happening? Now let us understand in very simple terms. When you put substitution in such questions, this substitution will reduce this into an old question that we already saw. In mathematics, the general method is to reduce unknown questions into known questions. This is very interesting and important to understand. Moving forward, now this question is given to you. If you are comfortable, you can pause the video and try solving this question. Those who can't, let me again follow through this question. Now what we are going to do is, we are going to divide by the highest power. So that will come when we divided by n plus 2 factorial. If I do so, this is limit n tends to infinity. 1 plus n plus 1 factorial divide by n plus 2 factorial, then divide by 1 minus n plus 1 factorial divide by n plus 2 factorial. You can see that n plus 2 factorial can be in turn written as n plus 2 into n plus 1 factorial. So what I am doing in simple terms is, if you have 6 factorial, can be written as 6 into 5 factorial. That is what is happening. So once you do that, this question reduces itself into limit n tends to infinity. This becomes 1 plus 1 by n plus 2 divided by 1 minus 1 by n plus 2. You can see that n is tending towards infinity. So what will happen if n tends toward infinity? N plus 2 will also tend towards infinity, and as a result 1 by n plus 2 will tend towards 0. So answer of this question becomes 1 by 1, or again extremely simple question based on previous knowledge. Again, now in this question we are trying to connect. Now if you know, you can again pause and try, but if you don't know, observe this root sign. Whenever you see a root, the idea into your mind should be rationalization. We need to rationalize. So if you rationalize, let us see what happens. This is limit n tends to infinity. After rationalization, let us first do it and then see what happens to this term. We will have to multiply and divide with n plus root of n square plus n plus root of n square plus n. If I have done this, it takes this form. Limit n tends to infinity, n square minus n square minus n divide by n plus root of n square plus n. These two terms cancel out, and now we are left with limit n tends to infinity minus n by n plus root of n square plus n. Once you have this, now you can divide by n and get the answer. So if I divide it by n, limit n tends to infinity, this becomes 1 plus root of 1 plus 1. If I put the limit to 1 by n, will tend towards 0. So answer becomes minus 1 by 1 plus root 1 or minus 1 by 2. Moving forward, now this is an unexpected question. What they are saying is there is x raised to the power n and then there is n factorial. Now, something different is happening in this question. Let us understand what they are trying to say. So x value, there is no restriction over it, the variation is terms of n only. So what we are saying is x raised to the power n by n factorial. Let us take some value of x and understand what happens. If I take the value of x as, let us say 3. What will happen? This will become 3 raised to the power n by n factorial. So if I try and understand, this is 3 into, let us write this n factorial as 1 into 2, 3 by 2, then 3 by 3, then 3 by 4, then 3 by 5, and this will go till n. So what you should understand is, see, as the value of x will increase, the chain will become longer. But idea is basically, if n is becoming infinity or tending to be a very big number, most of these terms, you can see that here these terms would be smaller than 0, smaller than 1 or tending towards 0. Wherein these terms that are written on this side are greater than 1. You can see that number of terms greater than 1 would be much smaller than 1. Reason is that n is tending towards infinity. So what is happening is, when these terms will become smaller and smaller and smaller, will multiply and become smaller and smaller, the overall value will move towards 0. So what is happening is, answer comes out to be 0. Why it is happening so? If I take a very big value, like you can try this, put the value of n as 100. As a result, what will happen? These terms that are in yellow will be much more and much smaller than to the terms that are greater than 1. Hence, the overall multiplication will come out to be very close to 0. Now, if I look into this 2024 question says that you have a series given in the numerator. Now, let us first find the sum of this series. Then there is one series given in the denominator. Let us find the sum of this series. And then divide them and apply the limits. Ideally, we should get the answer. So, let us start with the first limit first series first, the numerator ka series. So, you can see that the general term can be written as r square minus n into n minus n. You can check. Now, let us write this general term tr. If I write it down, answer becomes r square n minus r cube minus rn plus r square. As a result, you can simplify this and write minus r cube plus n plus 1 times r square and then minus nr. Now, if I want to write the sum till n terms, we will have to apply a summation over tr. As a result, it looks something like this. Summation of minus of r cube plus n plus 1 summation of r square minus n times summation of r. The first part can be written as n into n plus 1 whole square by 4. This is the standard result. The second one will become n plus 1 into n plus 1, 2n plus 1 by 6, and the last one will become n times n into n plus 1 divided. If you can write it like this, and it could be very easy simplified. Now, if I simplify this, you can see that the leading coefficient from here is 1 by 4. And if I simplify this, so the leading coefficient after simplification will become plus 2 by 6, n raised to the power 4. And then you will have something into n cube plus something into n square, something into n, then some constant. See, why I am not writing these and these terms after simplification, because this calculation is largely not required. Second part should be to go in the denominator. So what you have is, you can see that in the first part is summation of r cube. Then what you are writing is summation of r square. This can be written as n square, n plus 1 whole square by 4, standard formula. Second part also n into n plus 1, 2n plus 1 by 6. Now, once you have got this much, the next part would be to find the limit. So let us substitute in the limit given in the question in the third step and get the answer. So limit n tends to infinity, numerator becomes, if I simplify this, this will become 1 by 3 minus 1 by 4, it is nothing but 1 by 12, and this is n raised to the power 4, then something into n cube, then something into n square. Like this we can write till the last term. The denominator part, you can see that if I do it in the similar manner, you will get 1 by 4 times n raised to the power 4, something into n cube, something into n square, like this all the terms. You can see that if I divide by n raised to the power 4, what would be my answer? So limit n tends to infinity. This becomes 1 by 12 plus something into 1 by n, something into 1 by n square, all of these terms. And the denominator also 1 by 4. And largely the lower power terms are not going to play a very important part, because when I put this limit, and that is the reason you can see that this part, this part, this part and this part did not even calculate it here. I did not spend any energy in doing this. Why? Because ultimately these are not going to make an impact. So if I put the values, all of these terms, this and the remaining will become 0. Answer becomes 1 by 12 by 1 by 4. That is nothing but 1. I hope this is clear to you. Now, similar kind of question that came in 2022 we solved earlier. What you need to do in complicated question is to put the substitution. So n we can put as 1 by t. So when n tends to infinity, t will tend towards 0. This is what we have. So as a result, this becomes limit t tends to 0. This becomes root of 1 by t square minus 1 by t minus 1. This will become plus alpha by t plus beta. And this limit key value is given as 0. If I take LCM and take t outside, this will become root of 1 minus t square. This becomes divided by t. This is also alpha by t, and then this is beta. If I patiently write one more step, it would be very clear to me. So limit t tends to 0. Root of 1 minus t square plus alpha plus beta t by t. This should be equal to 0. If I look into this limit, you can see that in the next step, this is my first step. In the next step, when t is tending towards 0, in the numerator, if you very closely observe, this part will become 1. This part will become 0. This will remain alpha. And this will become 0. So the numerator is tending towards, and if you very clearly observe, the numerator is tending towards alpha plus 1, whereas denominator is becoming 0. So this answer will only be finite when it becomes 0 by 0 form, and as a result alpha plus 1 should also be equal to 0. As a result, the value of alpha comes out to be minus 1. After doing this part and substituting this value, I think it should become extremely simple. In the third step, it is limit t tends to 0. Numerator becomes 1 minus t square. This will become minus 1. This would become beta t divided by t is equal to 0. T tends to 0. Let us write this as 1 minus t square minus 1. This becomes beta equal to 0. And once you rationalize this part, this becomes a limit t tends to 0. 1 minus t square minus 1 divided by t and root of 1 minus t square plus 1 plus beta is equal to 0. Now once I simplify this, you can clearly see that this is getting cancelled out. 1t also gets cancelled out. And as a result, this becomes minus 1 minus t divided by root of 1 minus t square plus 1 plus beta is equal to 0. Now once I have written like this, and if I put the value of t is 0, the numerator becomes minus 1. The denominator becomes 1 plus 1 plus beta is equal to 0. And as a result, the value of beta comes out to be 1 by 2. Now once we have done this and got this answer, then let us see what happens. Now question says that what is the value of 8 times alpha plus beta. Now 8 times minus 1 plus 1 by 2 would be equal to 8 times minus 1 by 2. That comes out to be minus 4. Let us check which option matches. You can see that there is an option given to us, C option matches. If I look into this next question, it is very simple. What you can do is basically again take x raised to the power 6 common from the denominator. If I do that, let us take x cube common from the numerator. And if I do so, if I take this x cube common, there is another x cube waiting for me. This will become x raised to the power 6. Since I take x common inside this root sign, this will become 3 plus 1 by x plus root of 3 minus 1 by x raised to the power 6 plus root of 3 plus 1 by x minus root of 3 minus 1 by x raised to the power 6. And from the denominator again we have x raised to the power 6 that could come as common. And this becomes nothing but 1 plus root of 1 minus 1 by x square raised to the power 6 plus 1 minus root of 1 minus 1 by x square raised to the power 6. And now you can see that x tends to infinity. 1 by x will tend towards 0. If I apply this logic, you can see that what will happen. You can see that this term, this term, this term, this term, this and this will become 0. And if this becomes 0, what is my final answer? Also this x raised to the power 6 gets cancelled out. In the numerator you have root 3 plus root 3 raised to the power 6. This will become root 3 minus root of 3 raised to the power 6 divided by 1 plus 1 raised to the power 6 plus 1 minus 1 raised to the power. If I simplify, this is 2 root 3 raised to the power 6 by 2 raised to the power 6. This cancels out and this comes out to be 3 cube. That is equal to 27. Let us check the option. You can see that D option. Now this last question that came in 2023 seems difficult but is a very simple conceptual question. So what I can do is I can take this last term common, and if I do so, this becomes limit t tends to 0. If I take this common, the sine square will go away. Inside it becomes 1 by n raised to the y 1 by sine square t. The next term would be 2 by n raised to the power 1 by sine square t. Like this, all the terms will come, and finally there would be a 1. N by n, the n by n will become 1. Let me write n only. So once you have written it like this, this is what we have got. Now understand what is happening. See, when n is tending towards, t is tending towards 0, what will happen to sine t? Sine t will also tend towards 0. So what will happen to sine square t? This will also tend towards 0. So what will happen to its reciprocal? It will tend towards infinity. So this is what is happening. So what is happening is, you can see that these powers that you have written here, these are very big powers. These are very big numbers that are written here. So what is happening inside this, that is the important thing. This is a number that is between 0 and 1. So what happens is, if you have a number like 1 by 2, and if you put a very large number here, like 100, this will become 1 by 2 raised to the power 100, very close to 0. This is what we are saying. So what we are saying is, if you take this 1 by n, 2 by n, everything before this term, all the terms before this, because this is becoming 1, apart from that, all of this will become 0. So what is happening is, what we could see is n is fine, this becomes 0, this becomes 0 and this becomes 1. Now this part will also become 0. So this becomes 0. Your answer becomes nothing but n. That is nothing but option. In this video, we went into the idea of how to handle infinite limits. And largely I told you two very specific techniques, how to deal with simple questions and then how to deal with complicated questions. In the next one, we are going to deal with series expansion based questions. So if you are enjoying this series till now, I will highly recommend that you continue and watch it till the end. For all the students still facing problems with problem solving, I have made a detailed series just on solving previous year JEE questions and techniques required to solve all of those questions. The link of that course is in the description below. If you think that would be something useful for you, go and check that out as well. See you until next one. Bye.